Hi everyone, Mr. Chaffee here. We're going to be going over our first Keystone Review lesson today. We're going to cover a couple of different topics, starting off with comparing real numbers, then looking at our greatest common factors and least common multiples. So to do so, we're going to need to first take a look at a couple of vocab words. Let's see. First up, we've got our real numbers, the set of numbers comprised of rational and irrational numbers. These are the numbers that we've been encountering most of the time over the course of our math class this year. Then we have our rational numbers, numbers that can be expressed as the ratio, or a fraction, of two numbers. These include integers, decimals, and decimals that either terminate or repeat. So let's see, our rational numbers include numbers like 132 over 528, just any sort of fraction that we can come up with, or it could be a decimal that terminates, such as 1.67, or we could say it's a decimal that repeats, something like 0.3 repeating, where our 3 goes on over and over and over indefinitely. And also within these, our rational numbers, we could have integers like -2 or 31. Then we have our irrational numbers, which these are numbers that cannot be expressed as a ratio of two numbers, decimals that are non-terminating or non-repeating. So the most famous irrational number that we encounter most frequently would be pi, our 3.14159 ... that just goes on indefinitely and continues with no sort of pattern or repetition anywhere within our decimal there. So that's our one example of an irrational number. Then we have our integers, which are included within our rational numbers. Our positive and negative whole numbers here. So any positive and negative whole number make up our integers. And our number line, which I know we've worked with throughout the year, but just as a quick reminder of what our number line looks like, we just have a line, which is a visual depiction of how we can order numbers together. Usually we encounter these with integers, but we could put fractions or decimals here, whatever we like. I think integers are usually the easiest to work with, but starting from the left-hand side, we start with our smallest number, and that ascends upward towards our greater numbers on the right-hand side. We could use, again, any type of number that we'd want on our line, just to give us that visual representation of how to order numbers together. Now let's take a look at a couple of examples. So first up, we've got write the least number that can be made with the digits 9, 5, 2, and 8. Use each digit once. So if we're using each digit once, we're going to get a 4-digit number, something in the thousands. So let's see, if we want to make the least number that we can, we want our smallest digit to make up our biggest place. So in our thousandth place, let's use our 2. And then same thing, our next smallest digit would be our next biggest place. In the hundredth place goes 5, and then we're just going to count up 8, 9, giving us the smallest number we can make here as 2,589. All right, Liam correctly ordered the following numbers from least to greatest, and then we have 4 numbers right here. So what did you do wrong, Liam, if these are incorrect? We want to figure out which 2 numbers need to be reversed to make Liam's solution correct. So we're only switching around 2 of these numbers. Let's see, looking at our thousands place, they are all at least 3,000 something, so that part looks good. Our hundredths place, we've got a 2 in the hundredths place here, then a 3, a 3, and a 4. So our hundredths place looks good here. We're counting up from 2, 3, 3, and 4. So that means this number is for sure our smallest number. It's the only number with a 2 in the hundredths place. And here's our largest number, the only number with a 4 in the hundredths place. But now it looks like we have some discrepancy between these two middle numbers. So they both have 3's in the hundredths place. But now let's take a look at our tens place. We can see we have 5 and 4, giving us 54 and 45. So our 50s are going to be higher than our 40s, obviously, so we need to swap these two numbers around because our tens place digit is incorrect here. And let's see which letter choice aligns with our answers. We've got, looks like B, switch 3,354 and 3,345 because the tens digit is incorrect. Yes, that's the one that we want to go with here. So we just want to look again, one at a time, at each of our digits, starting with our largest one and moving down to make sure they are all in the correct place. All right, let's try another example together. Alex's fish tank holds 7.15 gallons of water. Mark's fish tank holds 7 1/5 gallons of water. Select all the statements that are correct. And then we have 4 different choices here. So why don't you go ahead and pause for a moment and see if you can figure out which of these answers are correct. There could be multiple here. I'll give you a moment to do that. All right, let's take a look at how I would go through and solve this problem. So we have 2 numbers here, 7.15 and 7 1/5. If we're going to want to compare these 2 numbers, we're going to need to either turn this into a fraction or this into a decimal. I'm going to go with the latter option here. I think that's a little bit easier. So we can say our 1/5 is equal to 2/10, which we know is equal to 0.2, or 2/10 there. So 7 1/5 we can say is equal to 7.2. Now if we want to compare, letter A says Alex and Mark's fish tank holds the same amount of water. Well, no they don't. Mark's holds 7.2, Alex's holds 7.15. So we can cross off letter choice A. Letter B says Mark's fish tank holds more water than Alex's. Well, Mark's holds looks like a little bit more. 7.2 is a little bit higher than 7.15. So yep, I would agree with letter B. We could say that is correct. Letter C says both fish tanks hold less than 7.5 gallons of water. And let's convert 7.5 to a decimal, which this one should be nice and easy. We get 7.5. And we can see that's bigger than both of these fish tanks. So letter choice C is correct here. And D we can disregard because we just said they both hold less than 7.5 gallons of water. All right, one more example on this page. Order the numbers from least to greatest, and then we have 4 numbers right here. So if we're starting with our least or our smallest number, we want to choose the number that's farthest away from 0 in the negative direction. That would be our negative 7.05. Our next farthest away number that's farthest away from 0 in the negative direction is our only other negative number here, our 6 4/7. Then we're in our positive numbers, and we could see, well, we know 2 2/5 is definitely less than 8. So we got our 2 2/5 and our 8, giving us our final order from least to greatest. So again, when we're doing these, we have a mix of negative and positive numbers. Our negative numbers, we know are our smallest numbers, so that's going to start on our left-hand side. Then we're just seeing which one's farthest away from 0, and then counting upwards in ascending order towards our positive numbers. Flipping the page over here, let's try out 2 more examples where we're comparing some numbers together. All right, we've got Jane and Akil went for a run. Jane ran 3 3/10 miles. Akil ran 3.25 miles. Select all the statements that are correct. All right, why don't you try this one out on your own again? I'll give you the moment to pause the video and see what you come up with. All right, let's try this out together. We can see, well, we have 2 numbers, one with a fraction and one with a decimal here. I'm going to, again, convert our fraction into a decimal so it's a little easier to compare them. We have 3 3/10. Well, that one's nice and easy. We have equal to 3 3/10. 3 in our tenths place there. Now, if we're saying Akil ran 1/2 mile more than Jane, well, 1/2 is equal to 0.5. If Akil were to run 1/2 mile more than Jane, that means he would have needed to run 3.8 miles, which that is incorrect here. He ran less than Jane, so we know that one's wrong. Akil ran a greater distance than Jane. Again, he ran slightly less. He only ran 3.25 miles. So we can disregard letter B. Letter C says Jane ran 1/20th of a mile more than Akil. Well, let's find the difference between these two. 3.30 minus 3.25. We subtract. Borrow 1 from our tenths place here. We get 10 minus 5, and then 0, 0, bringing down our decimal, making sure that's lined up. So the difference between these two is 0.05. And if we were to convert our 0.05 to a fraction, we should be getting 1/20th here. So C is correct. And then letter D, Jane ran more than 3 1/4 of a mile. Well, if we're looking for 3 1/4 of a mile, that's going to equal our 3.25. So that's exactly what Akil ran. And then Jane did run a little bit more here. She ran that 1/20 of a mile more. That makes letter D correct. All right, let's try out our last problem for this section. Which of the following is 0.3030 repeating written as a fraction? So we can actually use a nice little algebraic formula here to try and figure out, or create a little algebraic formula here to try and figure out how to convert this decimal into a fraction. So with our repeated decimals, what we want to do is take the portion of the decimal that repeats. So if we're going and looking at this decimal, we can see that the 0.30 is the part that repeats. And the first step in doing this is to multiply this by a power of 10, which gets the entirety of the repeating portion of the decimal over into a whole number value. So if we have 2 digits here, that means we want to multiply this by 100 to move it over 2 places. And when we do so, we're going to get 30.30 repeating. So now we have 30, and then we still have that repeating decimal. It's just been shifted over 2 units here, giving us another repeated decimal, but now with this whole number component. Then from there, we're going to want to take that answer and subtract away our original number. So I'm just going to subtract away our original repeating decimal here and find the difference between these two. Well, if this goes on and on and on forever, and so does this, they're repeating the same decimals over and over, and they're also in the same position over and over and over again. Once we subtract those two away, we're going to be left with nothing. They cancel one another out. In our comparing our whole numbers, we'd have 30 minus 0, which gives us a nice even 30. So now, let's see what we actually just did here. We could say a repeating number, we could define that as just x. And this top number, what we did is we took 100 times x, giving us 100x. So now, we can say that 100x minus one single x gives us a final answer of 30, which is what we just did with our finding our difference here. Now we just have a simple algebraic expression that we can solve, and when we do, we'll get 99x is equal to 30. Now let's divide both sides by 99, which will get us x is equal to 30 over 99. And if we simplify this fraction here, these both have a 3 in common, so we can say x is equal to 10 over 33 just by dividing out that 3 and simplifying, which is letter choice B.